Hi guys, here we are. So today we are going to derive the relation between PVT for adiabatic process. Okay, adiabatic process relation PVT. Okay, so to derive the relation between PVT and the adiabatic process, we have to first find what is P. We know that what is the governing equation of adiabatic process? It is this one, okay, this one, PV1 equal to C, okay. Now the second stage, it is just to find out what is we know the gas equation. It's like a perfect gas equation, PV equal to mRT. So we have to combine these two equations so that we can get the relation PVT in the relation in the adiabatic process. See, here we know that M and R, so PV raised to gamma is equal to C. We know that gamma, it is the ratio between the specific heat at constant pressure and specific heat at constant volume. Okay, C upon CV. Okay, these are the equation that you do not have to forget. And this one, R is Cp minus Cv. These are very important equations. Okay, now see here what we have to find. So here we have PV and T, and PV is something like this one. So we have to find here, suppose in here. So for here we know that mass of the gas doesn't change. Okay, it doesn't matter the temperature, the pressure, or the temperature or the volume. The mass of gas is the same mass of the gas, and also the constant gas characteristic constant doesn't change. Okay, it's a characteristic inherent to its substance. Okay, it is constant. So mr are constant. Okay, are constant, and I will call this constant C2. Here I will call C1, and here it is temperature, and here it's PV. So what I will find, I will just find the ratio between C1 and C2. From there I will find the relation between PVT in adiabatic process. So here C2 will be equal to PV upon T. Okay, C2 will be equal to this one, and here C1 is this guy. So ratio between them, okay, C1 upon C2, it is C. So whenever I have two constant and I divide, the ratio between two constant, it's always a constant. So then I will just put here this one, PV raised to gamma, okay, upon PV divided by T, okay, it's equal to C, it's constant. So whenever I have two expression like this one, we know that we cannot divide fraction. Okay, we keep the same. Okay, we keep the same fraction, the first fraction, and multiply by the inverse of the second. So here we will get what? PV raised to gamma time, okay, time upon PV. Okay, this pressure will be cancelled out, then V, and just dividing power properties, it will be V raised to gamma minus 1 time temperature equal to constant. Okay, this is the relation between temperature and volume for adiabatic process. And also, how if we want to find the relation between pressure and temperature? Okay, because here we have relation between pressure and volume. Okay, pressure and volume, what is the relation? P, okay, PV raised to lambda raised to gamma equal to C. Okay, here we have the relation between PV, VT. Now what is missing? Relation between T and P. And to find the relation between Tp, we will analyze these two expressions, okay? So for states, for state 1 and 2, okay? State 1 and 2. For state 1 and 2, here we got P1, V1 raised to gamma equal to P2, V2 raised to gamma. And here we will get V1, let me call this one, 2. Here we get V1 raised to gamma minus 1 time T1, and here V2 raised to gamma minus 1 time T2. So what do we have to do? That's the point. What do we have to do for this one? For these ones, what is needed? That's the point. So I want just to express temperature with respect to pressure. Okay? Now, I will just separate this one. So V1 go down, okay? And V1 also go down, and T1 come here, okay? In both equations, I will just do separate V. Just isolate V here and V here, so that V can be in one side and V can be in one side here for this one and for this one. For the first one, I will get V1 upon V2 raised to gamma equal to P2 upon P1. For the second, I will get V1, okay, upon V2, nice, upon V2 raised to gamma minus 1. It will be equal to what? It will be equal to, just send here, you send it will be equal to T2 upon T1. It's nice. Done. Now we know V1, V2, V1, V2. They are the same. The only difference is just in the sign, in this one, in this guy. Okay? Let me just use another paper. Now what we will get, now that I know that V1 here upon V2, raised to gamma, it is P2 upon P1. Now, what I will do, I will just make this one. This is gamma, nice? Okay, this is gamma. So, V1 upon V2 raised to gamma, I will put here 1 upon gamma in exponent. So that this one, because I want only V1 upon V2, then substitute in the second equation. Then 1 by n, 1 by gamma, and here I'll get P2 and P1. Okay, so this one, this guy, and also will be 1 by gamma. It's okay. Now from here, what we will get? We'll get V1 upon V2 is equal to, because this guy will cancel that with this one, is equal to P2 upon P1 raised to 1 upon gamma. Okay, raised to 1 upon gamma. What will I do? I will substitute in the second equation. What is the second equation? You remember this one. Okay, V1 upon V2, okay, this one raised to gamma minus 1 equal to T2 upon T1. So, where I find V1 upon V2, I will put this expression there. Then it will be, I know that it's V1, V2 raised to gamma minus 1 equal to T2 upon T1. So this V1 upon V2 is this one. So it implies that I will get P2 upon P1, just substitute, raised to gamma minus 1, okay, this all, okay, sorry, yeah, let me write this one, raised to 1, 1 upon gamma, 1 upon gamma, this is V1, V2, and this is raised to 1 raised to gamma minus 1, okay, it is equal to T2 upon T1. Now from here, what do you have? This is directly done, okay, this is directly done, this is directly found, that here you will get P2 upon P1, okay, it will be what? Gamma minus 1 upon gamma equal to T2 upon T1. Okay, equal to T2 upon T1. Okay, so this will be the relation between pressure and temperature. Okay, the relation between pressure and temperature. What does it mean? That's the point. So what does it mean? It means that if I put this one here down here, I will get this one. So this one, as you can see. So just put on this and put on this. So it means that P2, P1, T2, T1. Okay, I will just consider this T2, T1 and P2, P1. What will it be? It will be this one. This will be, if it is P2, P1, I will consider this as P. Okay, as P. And this one, if it is T2, T1, I will consider this as T only. Gamma minus 1, gamma is equal to T. Okay, so then I just divide it all. Divide it all by P raised to gamma minus 1 upon up to gamma. Okay, so I will get what? I will get, if I divide it all, I will get here 1. This will be 1. What is 1? It's a number. There will be a number. This number is a constant. Okay, let me call this, it will be constant and number, because when I divide this one by the heat itself, it will be 1. So this will be constant. It will be this temperature upon P raised to gamma minus 1 upon gamma. Okay, upon gamma. Okay, this is the relation between temperature and pressure of this one. So then we are done. Let me do this in a simple way. So for adiabatic process, okay, for adiabatic process, PVT relation R TV raised to gamma minus 1 is constant, and T upon P gamma minus 1 minus this one, okay, this is constant also, and TV raised to gamma is constant. These are the three, okay, relation that we have for adiabatic process. Okay, and we will use this too many times. Okay, too many times. Okay, now what is the adiabatic? What is how if we want to find the work done for adiabatic process? Okay, the work done. Okay, work done for adiabatic. Okay, work done for adiabatic process. It will be, first you have to draw, okay, adiabatic process. Okay, it is the same, PV raised to gamma equal to C. Okay, if you just send this guy down, you'll get P equal to C upon V raised to gamma. So this expression here, the graphic of this guy will be this line, just like this one. Will be almost similar to isothermal, but this one will get more, will be more, how can I say, more stretched or more curved. Okay, we'll get more slope. Okay, so this is V1, this is V2, okay, this is P and V. So the work done in here for the adiabatic process, it will be the same, V2, V1, it will be P, D, V. Okay, now for here, what do we have to do? We have just to find from this equation for the adiabatic process, we will just find what is P. P will be C upon V raised to gamma. So from here, I will get V2, V1. So P is C upon, it will be C upon what? C upon V raised to gamma, B, V. So this is C, and just solve this integration. Okay, dV upon V raised to gamma. Okay, just solve this integration, you will find what is work done for this one. This is C, okay, this is C. This integration will be what? This will be what? This will be, this integration will be what? Will be directly V raised to gamma minus, not minus, so minus V raised to gamma plus 1 upon minus gamma plus 1. This V raised to minus gamma plus 1 and this one and this one. So this will be C, and here what will I get? I will get this gamma minus 1, this we know. This will be V2, this is in between V2 and V1. This will be V2 raised to minus gamma plus 1, okay? Minus V1 raised to minus gamma plus 1, okay? Plus 1. Here, minus gamma plus 1. Okay? Just like this. And here, what is C? That's the point. C is PV. Okay, so C can be substituted by P and V raised to gamma. Okay, if you multiply this PV raised to gamma, this is V2 gamma, okay, V2 gamma negative time V2 minus V1 gamma negative time V1, all of this upon, okay, 1 minus gamma. Now see, if I just multiply this V, it is not V2 neither V1. This can be V2 or can be V1. So when I multiply this to this and this to this, so it will gain this, when it multiply with this will be V2. When multiply with this will be V1, because this V is for all of them. Okay? Just for this. So then you will get, and here P also. So when you multiply this 2 by this guy, this will be P2, okay? Then V2 raised to gamma minus V2 raised to minus gamma, then V2 minus P1 V1 raised to gamma time V1 raised to minus gamma time V1. This all divided by 1 minus gamma. Okay, so in here what we will get, if you check this one will be cancelled out by this one. This will be 1. This also will be 1. So I will get P2 V2, okay, I got P2 V2 minus P1 V1, okay, P2 V2 minus P1 V1. Let me use the backspace, the back front of this. Okay, remember what we got here between P2 V2 minus P1 V1. So work done will be P2 V2 minus P1 V1 upon 1 minus gamma. See, 1 minus gamma. How if this is the same? Gamma is always greater than 1. Okay, so then I have just to do this one. Gamma minus 1. This will be negative. And this is P2 V2 minus P1 V1. Then it will be just this minus will multiply all of this expression. It is all this will be 1. I will just change the sign on this one. P1 and here P2 V2 gamma minus 1. This is the work done for adiabatic process, minus P2 V2 upon gamma minus 1. This is the work done. Okay, and this work done, as you can see, can be also expressed in this way. See? This is P1 V1 minus P2 V2. This can be also expressed in this way. Minus, if you take out minus here, it will be what? M, okay, MR T2 minus T1 upon gamma minus 1. Just take out, this is MRT1 minus MRT2, okay? If you take out this minus, this will be minus, will be positive, take out the minus here, then you'll get this one in this way. And this is the same as writing this one, see? This is the same as you write this one. This will be minus MR delta T upon gamma minus 1. Okay, so yeah. And we can play also here a little bit. See, MR delta T, and here it's negative, nice, upon gamma minus 1. C, what is, we know that Cp minus Cv is equal to R. Now divide it all by CV. CV. It will be Cp upon Cv minus 1. It will be R upon Cv. Now this one is gamma minus 1. This is R upon Cv. It means that this R is equal to what? This guy come here. Cv gamma minus 1, and here it will be R. Okay, so R is Cv times gamma minus 1. Okay, so from here you can just directly come here and say this will be minus this one. What is R? Cv. Okay, we know, see, this is this one. Nice. If we substitute this one, what we will get? M Cv gamma minus 1 delta T upon gamma minus 1. So gamma minus 1, gamma minus 1. You will end and you will say that the work done is equal to minus mCv delta T. And this is not lie, because remember, this is mCv delta T. What is this? This is work done is equal to minus delta U. Okay? And this is not a lie, because we know that here for adiabatic process, heat transfer is 0. So work done plus delta U is 0. Now find work done will be what? Minus delta U. You see, you can prove it anyway and so on. Thank you. This is almost done. This is done. So now that we know what is work done, that is the same. Okay, just let me just put it here. So here work done, it is the same, minus delta U, but that is m Cv delta T. Okay, this is also the true. This is also true. Minus. Okay. Now let us jump for another one. What is another task? Another task, it is what is what is after working done? What is internal energy? Delta U will be the same. Okay, mCv delta T for this process. This will be the same. So, and also the enthalpy delta, this one, enthalpy will also be the same, because you will get P2 V2 minus P1 V1. Okay, enthalpy will be the same, plus U2 minus U1. Just try to find out this expression at all of this will be M R delta T plus M Cv delta T. Okay, just then this R is Cp minus Cv, and you will end with the same. Okay, knowing this, so this will be M R. What is R? Cp minus Cv, and here is delta T plus mCv delta T. So from here you will find mCp, okay, delta T minus mCv delta T plus mCv delta T. This will be cancelled out with this. So change in enthalpy will be mCp delta T. Okay, very easy. That's okay. Now, what will be the heat transfer for this process? 0. Okay, we are done with the adiabatic process then. It's okay. Thank you. I hope you can all be well. Next time we see you.